Alright, so Unit 10, Day 5, this is what's called the unit circle, and we call it the unit circle because we think of it as a circle with a radius of 1, and it's going to be extremely helpful for us to find cosine and sine and even tangent of some really common angles that we're going to be using. So when we're doing this, again, this is a tool that's meant to be quicker than using a calculator, and it's actually more exact than using a calculator. And it's all based off of the 3 right triangles, or I should say the 2 kinds of right triangles that we memorize, the special right triangles, being the 45, 45, 90, and then I say 3 because these are actually laying 2 different ways, 30, 60, 90, and 60, 30, 90, however you want to say it. I mean, but just the way it's oriented. So, so first off, let's just label these before we get into any other stuff. Remember, if this is a 1, okay, so the hypotenuse of a 45, 45, 90 triangle is a 1, what is the leg going to be of this? And remember, you need to divide by radical 2 going this way. So this would be 1 over radical 2. If I rationalize that, I multiply by radical 2 over radical 2, it'd be radical 2 over 2. And this would also be radical 2 over 2. Okay, so keep that in mind. This guy here, if this was a 1, then the small side would be a half, and then I'd multiply a half by radical 3. So it'd be 1 over 2 times radical 3, which would just be radical 3 over 2. And then if it's oriented this way, this would be the 1/2, and this would be the radical 3 over 2. So keep those in mind with what we're about to do. So first off, if you need to, you might want to tear this out, this paper out. The next page, if you flip it, I just ripped mine out to give me space here. And we're going to, the learning target is I can build the unit circle by labeling all special triangles in degrees and radians, as well as the sine, cosine, and tangent of each. And I can use the unit circle to find trig values without a calculator. So on the unit circle provided, again, keep in mind, this radius is 1, so all of these lengths are going to be 1. Okay, and we think of this as the center at the origin, 0, 0. So this is a coordinate plane. Okay, so step 1 here, we're going to write the degree and radian measures along the corresponding coordinates and the slope. So first off, if this right here, if this is 0, 0, what would be the coordinate of this point right here? If this is a radius of 1, well, it would be 1, 0. That's a coordinate of that point. Now the degree measure of this is 0 degrees or 0 pi radians, or you could do 360 degrees or 2 pi radians. I'm going to leave radians off. So let's go around. So up here, this would be 90 degrees. I might turn it this way a little bit. I'll say 90 degrees or pi over 2. So it's going to be 90 degrees or pi over 2. Now, if I went straight up 1 unit, what would be the coordinate of that point? The coordinate of that point would be right 0, up 1. Okay, so that's the coordinate of this point right here, if that is the origin. Let's go over here now. So this line right here, the measure of that would be 180 degrees or pi radians. Now, if I went 1 unit to the left, the coordinates at that point would be -1, 0. Okay. And then the last one we've talked about here, so this would be, I'll turn it this way, it'd be 270 degrees or 3 pi over 2 radians. And if I went straight down, okay, this would be 0 to the right, down 1. That would be a coordinate of that point right there. Okay, so we're looking at these points on the ends here. What would be the coordinates of those points? Next I want to put right below it the slope of this line. To get to this point, it would be rise 0, run 1. So it would be a 0 over 1, so I'm just going to put 0 below it. Okay, now here, this would be a rise of 1 and a run of 0, so 1 over 0, which would be undefined. Okay, now we're going to use that later. Here, the rise is 0, the run is -1. Well, that's still 0. because 0 over -1 is still 0. So the rise, it went up, none, left 1. That's still a flat line, so the slope is 0. And then down here, the rise is -1 over the run, which is 0. So -1 over 0, -1 over 0 equals undefined. And that will be important in a bit. So let's first off, let's do these 45, 45, 90 triangles. Okay, so if 45, 45, so I'm looking for a 45 degree. If you look at right here, here is a 45, 45, 90 triangle. If I drop that straight down, think of that, that's a 45, 45, 90 triangle. If this is 1, let's do this too. This is 45 degrees, or pi over 4 radian. Well, if this length is 1, how far to the right do I go and how far up do I go? Well, we said that if the hypotenuse is 1, you'd go right, it'd be a radical 2 over 2 and up radical 2 over 2. So this would be over radical 2 over 2, up radical 2 over 2. So the coordinates of this point would be radical 2 over 2. That's how far to the right we went. How far up did we go? Radical 2 over 2. Now if I look at this and I flip this 45, 45, 90 over, and look at this right here. So there's another 45, 45, 90 triangle right there. Now what's this angle measure right here? This one is, we went 90 and then 45 more, so that'd be 135 degrees. Or it'd be 3 pi over 4, because we went 90 degrees and then 45 more. So this length right here, again, is going to be radical 2 over 2. So here I went right radical 2 over 2. Here I'm going to go left radical 2 over 2. And notice it's the same amount up, too. So the only difference is I went left this time. So it'd be left radical 2 over 2, comma, radical 2 over 2. That one. Now if I keep going straight down here, right there's another 45, 45, 90 triangle. Okay? And this would be 180 degrees plus 45 more, that's 225 degrees. And that would be pi plus another fourth, so it'd be 5 pi over 4 down there. I'm going just as far left, so it's still a negative radical 2 over 2, but in this case, instead of going up, I went down. If you flip this over, I went down. So this coordinate right here would be negative radical 2 over 2, comma, negative radical 2 over 2. And if you flip this over here to that one, or I think flip this one down, if I keep this down, there's another 45, 45, 90 triangle right there. Now this would be 270 plus 45 more. That's 315. I'm sorry, this one here. So 270 plus 45 more would be 315. So 315 degrees, which would be the same thing as 7 pi over 4. So this point right here, I go right radical 2 over 2, but then I have to go down radical 2 over 2. So this would be radical 2 over 2, comma, negative radical 2 over 2. Okay, so there I've got some things filled out. Now, the thing about this, if I look at this 45, 45, 90 triangle, if I'm looking at the angle, which I know maybe it helps to look at it this way too. If I'm looking at this angle, this ratio to that ratio, so the adjacent to the hypotenuse would be the cosine ratio. So this number is actually the cosine. Since it's over 1, it's just going to be that number. In fact, all of these, the hypotenuse of every triangle I'm going to make here is 1. So if I do the sine or the cosine, cosine is over hypotenuse, and so the sine, they're going to be over 1. So really these coordinates are telling me answers. Like this would be the cosine. So the cosine ratio, the adjacent over hypotenuse, is radical 2 over 2 over 1, which is radical 2 over 2. The sine ratio is opposite over hypotenuse. Well, since it's over 1, then that side is actually the sine ratio. The y-coordinate is actually the sine ratio. Okay, I'm going to go a little bit faster here. Let's see, look at this. This right here, the 30, 60, 90 triangle. So 30 degrees, well right here is 30 degrees. So this one is 30 degrees, which is the same thing as pi over 6. And if I drop that down and make a triangle out of it, so see the triangle, the 30, 60, 90 triangle. We go right radical 3 over 2, up a half. Right radical 3 over 2 up a half. So the coordinates of this point would be radical 3 over 2, comma 1/2. Okay, mirror this guy over. Over here's another 30, 60, 90 triangle, but I'm on the left this time. So it'd be left radical 3 over 2, comma 1/2. Flip it down. This coordinate is going to be left radical 3 over 2, but it's also down 1/2, so they're both negative. And then over here, if I flip this one down, positive radical 3 over 2, but down 1/2, so it'd be positive radical 3 over 2, comma, negative 1/2. So it'd be a negative 1/2 over there. Let's fill in these. So this would be 180, come back 30 degrees, that'd be 150 degrees, which is the same thing as 5 pi over 6. 180 plus 30 more would be 210 degrees, which is the same thing as 7 pi over 6. Over here, this is actually negative 30 degrees, so it would be 360 minus 30 degrees, so it would be 330 degrees, or let's see, 2 pi minus a 6 will be 11 pi over 6. Okay, now we're just missing a few more. The ones we were missing are the 30, 60, 90 triangles that are oriented this way with the 60 degrees. So it's a half, right half, up, radical 3 over 2. So right here is 60 degrees. If I drop that triangle down there, you see a 30, 60, 90 triangle where this is 60 degrees, which is pi over 3. This is right 1/2, and then up radical 3 over 2. So it's basically these numbers flip-flopped because I flipped it over, so now my right is what was up, so it's going to be right 1/2, up radical 3 over 2. Okay, flip it this way, here's another one right here, another 30, 60, 90 triangle. So if this is 60 degrees, then that means that's 30 over here. So 90 plus 30 is 120. 120 degrees, which is the same thing as 2 pi over 3. And instead of going right 1/2, I'm going left 1/2. So it'd be negative 1/2 would be this coordinate, but then it'd be up radical 3 over 2. Okay, flip this guy down here. It'd be left 1/2, and it'd be down radical 3 over 2. Now, what would the angle measure for that be? Well, if this is 60 degrees right here, that means this side would be 30. So we're 30 degrees short of 270, so that would be 240 degrees, or 4 pi over 3. And then flip it this way, or you can take this, flip it down. There's another 30, 60, 90 triangle where 60 degrees is in here. So it's going to be right 1/2 still, but now it's going to be down radical 3 over 2. So it'll be right 1/2, down radical 3 over 2. And then this would be, if that's 60 degrees right there, that means it's 60 degrees short of 360, because a full circle is 360, but come back 60, so it'd be 300 degrees, or 5 pi over 3. So I've just created this unit circle, and like I said, all of these, the first coordinates of these, are the cosine, and that's actually going to be a backside here. All these are the cosine ratios. It says, what does the x coordinate in each pair represent? That's the cosine ratio. So this is going to be the cosine theta ratio. What does the y represent? The sine ratio. Okay, because how far up you went, think about these triangles here, how far up you went was always the opposite side, and the opposite over the hypotenuse is the sine ratio. Opposite over 1 is just the opposite. So all of these, all the y coordinates are the sine ratios. Okay. Now the slope of these guys, I got into a little bit here. I have 1 over 0. Now look at 90. Let's try tangent of 90. So if I do tangent 90, what happens? Can't do it. What about down here, 270? Well, I got undefined here. Let's try tangent. So tangent of 270, undefined. Well, what if okay, let's go back to this guy. Let's do the rise over the run as the y over the x. If I did a half, so let's do 1/2 over radical 3 over 2, the rise over the run. Well, if I flip that over, that'd be 2 over radical 3, which would, if I cancel out the 2's, would be 1 over radical 3. And if you rationalize that, that'd be radical 3 over 3. So second, whoops, get out of there. So radical 3 divided by 3 is 0.577. Let's try the tangent of that angle. The tangent of 30, it's the same thing. So if you took the y over the x, the slope of this guy, what does the slope of the angle represent? Well, slope equals the y over the x, which equals the sine over the cosine. That happens to equal the tangent. This is always true, by the way. So tangent is the answer. But if you ever wanted the tangent, and you already know the sine and the cosine, you can actually divide those ratios and you'll get the tangent ratio. Okay. So now, how do we use this? Okay, so this is going to be a little bit faster. The video is getting longer than I want, but that's okay. So sine of 225. So first off here, go to 225. Now, which one's the sine ratio? Well, this one doesn't matter because they're the same, but the sine ratio is the y. So this would be negative radical 2 over 2 is my answer. I don't want decimals on this. Okay, you type in a calculator and give me a decimal and type it in, it's going to be wrong because we want exact. Tangent of 7 pi over 6. We'll find 7 pi over 6, which is right here, 7 pi over 6. I want the tangent ratio, which means I got to take the cosine over the sine. Cosine is, I'm sorry, the sine over the cosine. I said that backwards. So the sine over the cosine, which is 1/2 over negative radical 3 over 2. Flip this over, so this would be times negative 2 over radical 3. You can't divide by a fraction, we can multiply the reciprocal. This is negative 1 over radical 3. If I rationalize that, so radical 3 over radical 3, that'd be a negative radical 3 over 3. That's my exact answer. So if I give you tangent, you just got to do cosine over sine. You got to divide them. Cosine of 5 pi over 3. So I'm going to go to 5 pi over 3. Now 5 pi over 3 is more than 1, so it's going to be on the bottom half of the circle. So 5 pi over 3, scan through, look for it. There's 5 pi over 3 right there. So if I want the cosine ratio, it's the x coordinate. Okay. I want you to go ahead and finish this. I'm gonna pause the video and fill the answers in, and then you can check yourself as you go. Just because the video is getting long, but pause the video, try to answer these, at least half of them. Try to answer at least half of them, if not all of them, and see if you're doing it right. Okay, so here's the rest of them. As you're going through on some of these, when we got to the tangent of 3 pi over 2, that was one where 3 pi over 2 is right here. The sine over the cosine is negative 1 over 0. Can't divide by 0, so it's undefined. Can't find it. On some of these, like whenever you rotate it negative 150 degrees, negative 150 would be going this way, so you'd be 30 degrees short, so you'd be right there. So that would also be the same thing as 210, so that's where that answer came from. Negative 150 is the same thing as cosine of 210. I should have wrote that in there. 495, that's a full circle. So do 495 minus 360. That'd be 135. So that's the same thing as cosine 135, coterminal kind of stuff. So hopefully that helps. Let me know if you have questions, and yeah.